This lesson is all about circles. The definition of a circle is that a circle is the set of all points in a plane that are equidistant from a point hk. Now we all know what a circle looks like, but how does that knowledge mesh with this definition? So if I have a set of points in a plane, what that means is I have a set of points that are in a flat surface. And our two-dimensional graph that we draw are on a plane. So let's look at a circle. All right, so I have basically an x and y axis, so that puts me on a plane. And I have a circle on that. This point right here, right in the center, that's the coordinates given as hk. So the center of the circle is hk. And what this means is that any point that I pick on the circle itself, I could give the coordinates xy. The distance between hk and xy stays the same all the way around. So this distance here, which we call r, the radius of the circle, is the same all the way around. So the center is located with the coordinates hk, and the radius, lowercase r. Now, if we're talking about the distance between 2 points on a plane, we can use the distance formula to help us out. So the distance formula, that looks like d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So that will locate the distance between any 2 points in a plane. Well, I do have 2 points here. I have hk and I have xy. And I know that distance as well. That distance is equal to r. So let me plug that in. So the distance I'm going to change to r. And when I subtract the two x values that I have, I could write it as x minus h quantity squared. And when I subtract the y values of these 2 points in question, I could express that as y minus k quantity squared. And instead of expressing this as a square root, I could write this as what's called the standard form of a circle, which looks like x minus h quantity squared plus y minus k quantity squared equals r squared. Exactly what I had just a second ago. I just squared both sides of the equation to get rid of that, not to get rid of the square root, but to make it look more presentable. So I just took this side of the equation, squared it, and I took this side of the equation and squared it. So that's why I have r squared. And also I moved the r squared to the right side of the equation, but that's it. Let's look at some examples of working with this. So the first example is to find the equation of a circle in standard form whose radius is 3 and is centered at the point 5, negative 4. So we just need to make sure we remember x minus h squared plus y minus k squared equals r squared. So in this situation, I have a radius of 3. So from this, I learned that r is equal to 3. And the center is at 5, negative 4. So the 5 is my h, and the negative 4 is my k. Basically, I just need to plug these numbers in. So the equation of the circle in standard form is going to be x minus 5 quantity squared And notice it's a positive 5 in the point, but it's a negative 5 in the equation of the circle because the equation of the circle says x minus h. Similarly, I'm going to write y plus 4 quantity squared because when I do y minus k, it's y minus negative 4, which becomes y plus 4, equals 9, because 3 squared is 9. Okay? Find the center and radius of the circle whose equation in standard form is x squared plus y plus 1 squared equals 10. Well, to identify the center and radius, we need it in the center radius form, which is another way of saying standard form. So if you see in the homework asking for something in center radius form of the circle, it's the same thing as a standard form. So this really already is, but you just kind of have to think of the x as like x plus 0 quantity squared plus y plus 1 quantity squared equals 10. So that the center is identifiable at the coordinates 0, negative 1, and the radius, be careful not to just say 10 here, because 10 is the square of your radius. It's the square root of 10 that would be your radius in this case. Number 3, find the equation of the circle that has the following graph. In order to do this, all we need to do is identify the center of the circle and figure out what the radius is. So the center of the circle looks to me like it's located at the coordinates negative 2 on the x, positive 3 on the y. Because if I move over this way, that's 3, and that's at negative 2. So there's my center. The radius is going to be the distance between the center and any point. The point that you should use should be the point that's either directly to the right or left of the center or directly above or below the center. That's going to be the easiest distances to calculate. So here, if you count over 1, 2, 3, the radius is 3. So I have a center located at negative 2, 3, and my radius is 3. So the equation of this circle is going to be x plus 2 quantity squared plus y minus 3 quantity squared equals 9. There's different equations of circles, but they're all revolving around the same basic equation. So we've identified standard form, and we've looked at that already. That's probably the one you'll work with directly the most. But remember that it is also known as center radius form of a circle. Then there's also general form. General form looks like this: x squared plus y squared plus ax plus by plus c equals 0. And general form is basically if you take standard form and expand out the squares and combine all your like terms, you'll end up in general form. Similarly, if you start from general form and use the completing the square process, you can then go back to standard form. So let's take a look at that. For example, let's express the circle described by the equation x minus 2 quantity squared plus y plus 4 quantity squared equals 10 in general form. So we begin with the equation as is. And our job is to take this equation and FOIL out these binomials and expand them as far as we can and combine all the like terms. So for instance, if I have x minus 2 quantity squared, then that can work out to x squared minus 4x plus 4. And if you're not exactly sure how I did that, recall that when you have a plus b quantity squared, that results in a squared plus 2ab plus b squared. And that's what I'm working on to FOIL that out. However, you can always express it as x minus 2 times the quantity x minus 2 and use FOIL and come up with the same result. Similarly, this one becomes y squared plus 8y plus 16 equals 10. And now I look for like terms. So I have x squared plus y squared minus 4x plus 8y. So no like terms yet, but I do have the 4 and the 16, which would combine into 20. And I'm going to bring my 10 over. So I'm going to subtract 10 from both sides, which is going to give me x squared plus y squared minus 4x plus 8y plus 10 equals 0. That's the general form of this equation. Now, there's not many times that you would actually purposefully go from standard form into general form. It's more likely that you would go the other way around. So let's look at an example of that. Express the equation x squared plus y squared plus 2x minus 6y minus 6 equals 0 in center radius form. Then graph the circle. In order to do this, the first thing that I need to do is group together my x's. And I'll leave a little space because I'm going to use the process of completing the square here. Then group together my y variables. And I'm going to move the constant to the other side. So that's my initial startup. Next, what I'm going to do is, through this process of completing the square, remember we take the b term in a quadratic, we divide it by 2, and then we square it. So my b term in this first quadratic is 2. So I take 2 divided by 2, which is 1. 1 squared is 1. So I'm going to add 1 right here, and also on the other side to keep things balanced. Similarly, in this quadratic, the b term is negative 6. Now if I take negative 6 divided by 2, that's 3. And when I square 3, I get 9. So I'm going to add 9 to both sides of this equation. Now, this factors into x plus 1 quantity squared. And again, I'm using that formula for factoring that I showed you in the last slide. And if you're unsure how it factors or how that formula works, go through the details of finding two numbers that multiply to 1, but then add up to 2. You'll result in the same factorization. This one becomes y minus 3 quantity squared. And when I add everything on the right-hand side together, I get 16. So now I have it in center radius form, and I can use that for graphing. So let me get a graph here that I can work with. Okay. And from my equation, which was x plus 1 quantity squared plus y minus 3 quantity squared equals 16, the center of that equation is located at negative 1, 3, and the radius is 4. The square root of 16 is 4. So what I need to do then is locate my center. So -1, +3. That's at this point right here. Now I'm just going to go 4 units to the right. 1, 2, 3, 4. That's another point on my circle. 4 units to the left. 1, 2, 3, 4. There's another point on my circle. Above and below. So my circle is going to pass through these points here, and I'll do my best to draw, a reasonable looking circle here. That's not too bad at all. So now I've graphed my circle. Okay, in this last example, I'd like to show you how to input your graphs in your homework. So for instance, here's a homework problem that says to find the center radius form of the equation of the circle and graph it. So I have a center that's located at the coordinates -2, 0. And the radius here is 4. So plugging that into the standard form of the equation, the standard form of a circle, it's going to look like x plus 2 quantity squared. The y plus 0 I'm just going to leave as y squared, that's the simplest form, equals 16. So that is the equation. Now, in order to type that in, sometimes you need to take advantage of the different tools that are available to you along the baseline here of the problem. So for instance, I can type in x plus 2 just fine, but when I need an exponent, you come over here to this superscript, and you can type in a square, then just hit the right arrow key to get out of the square, and then you're typing back in line. So then plus y, and I need another exponent, squared, right arrow gets me out of that, equals 16. Once you've typed that in, hit check answer, and you should get it right. Then it's time to graph. So in order to graph, I'm going to enlarge it first so that it's easier to see. And you're not going to freehand these. There's some tools over here that let you do different types of graphs. So we have lines, absolute value graphs, parabolas, and circles. So let's click on the circle tool. And when you do that, you're first looking for the center of the circle. So just find where the center would be. It's at -2 on the x, 0 on the y, so right here. So I'm just going to click there. And then when I move my mouse away, it's going to draw my circle for me. Now, the radius is 4, so I just need to go 1, 2, 3, 4 units away, and then click again. And that's going to give me my circle. So hit save, check answer, and we're all set. Okay, one more example. This time we just need to convert an equation from general form into standard form, which is the center radius form, of course. We don't need to graph in the end, but the reason that this problem will be a little bit more challenging is that we have some coefficients on our x squared and y squared terms, and we're going to see some fractions along the way. So a bit more difficult arithmetically. So the process of completing the square, the first thing that we need to do is separate the x values and the y values and get the constant to the other side. So if I separate my x values, I would have 4x squared minus 36x plus 4y squared minus 28y equals -66. So I'm just going to move that -66 to the other side. Now, in completing the square, I have to have my leading term
be a perfect square. So x squared is fine, y squared is fine, but 4x squared is problematic. In order to handle that, I need to factor out the 4. So I'm going to take 4 out of this set of parentheses, which would leave me with x squared minus 9x. And then I'll leave a little bit of space for completing the square. I'm going to do the same in the second set of parentheses, just factor out a 4, which will leave me with y squared minus 7y. And that equals negative 66. Now, in order to complete the square, the thing that I'm going to need to do, it's the same process. I take the number multiplying my x, which in this case is a 9. So I'm going to take 9, divide that by 2, and then square it. When you square a fraction, it actually is fairly simple operation. You just need to square the numerator and denominator separately. So 9 squared, and technically speaking, this is negative 9 halves, but I'm going to square it, so it's going to become positive anyway. So 9 squared is 81, 2 squared is 4. So what I would do is add 81/4 right there. All right, now in order to balance everything out, the thing that I have to pay attention to is I can't simply just add 81/4 over here, because the problem with that is I'm not actually adding 81/4 right here. Everything in this set of parentheses is being multiplied by 4. So this is actually 81/4 times 4. 81/4 times 4 is just 81. So what I need to do is add 81 over here on this side. Similarly, if I have, let me get a different color. In this other set of parentheses, my middle value here, the term multiplying y, is negative 7. So if I take negative 7, divide it by 2 in order to do the step of completing the square, and then square that term. Negative 7 squared is 49. 2 squared is 4. Again, just square the numerator and denominator separately. So right here, I would be adding 49/4. But again, everything in this set of parentheses is multiplied by this 4 right here. So 4 times 49/4 is 49. So in effect, I would be adding 49 over here on this side of the equation. Okay, now let's simplify things a bit. So still have my 4 out here, but this is now a perfect square trinomial. And it always factors into x plus, in this case it's a minus, but we say plus just in general. So x minus this number divided by 2, quantity squared. And if you want to check it, go right ahead. You can FOIL this out. You'll find that this FOILs out exactly to x squared minus 9x plus 81/4. And similarly, this will factor into 4 times y minus half of this number, so 7/2, quantity squared. And all these need to add together. So let's see, if I add 1 and 49 would give me 50, plus 80 would give me 130, minus 66 looks like that would give me 64. Okay, I'm almost done. I still have these multipliers of 4 over here, and you're not in standard form until you get rid of any multipliers on your coefficient on these terms here. So in effect, I need to divide both sides of this equation by 4 to take care of that. When I divide a polynomial by a number, I have to divide each term by that. So that gives me x minus 9/2 squared plus y minus 7/2 squared. And 64 divided by 4 is 16. So that I am now in center radius form. The center of my circle is located at 9/2 and 7/2. And then the radius is the square root of 16, which is 4.